Sivatherium was a Pleistocene megafaunal browser, extinct long before recorded history. This is their story. First, let's get a grasp on our vocabulary. Sivatherium. The name Sivatherium means Shiva's beast. The first known fossils were identified in the Sivalik Hills of India, hence the namesake. Megafauna. A species is considered a megafauna if its adult body mass exceeds 44 kilograms, or, in stricter paleoecological contexts, it exceeds 100 kilograms. Megafauna actually impact vegetation and landscapes, these are called keystone herbivores, control prey populations, these are called apex predators, and modify soil, water, or forest structure with migration patterns and daily travel pathways. Ruminant. An even-toed ungulate mammal that chews the cud, regurgitated from its rumen. The ruminants comprise the cattle, sheep, antelopes, deer, giraffes, and their relatives. Giraffid. Giraffids are any member of the Giraffidae family, which includes modern giraffes, okapis, and extinct relatives like Sivatherium and its more giraffe-like counterpart, Sivatherium. Ossicones. The horn-like bony structures covered in skin and hair found on giraffids. Sivatherium had two pairs, one small and one massive. Ossicones are used by male giraffes as weapons for combat to establish dominance and mating rights, with the extra weight and structure of the ossicones delivering more powerful blows during necking. They also have a potential role in thermoregulation, helping to dissipate heat, and can be a factor in social hierarchy and sexual display. While antlers grow and shed, ossicones do not. So the size and appearance of the ossicones, particularly the baldness on top due to frequent combat, can be a sign of a male's age and experience. Now, let's talk about the scope of our timeline. The Earth is billions of years old, and all of Earth's history is organized into a series of epochs. Epochs are millions of years long and are demarcated by major geological, climate, or evolutionary events, which are identified through changes in rock layers, fossil records, and climate indicators. I'll talk about a few epochs here, but you should know that there are more than what we'll cover today. The epochs relevant to today's topic are the Miocene, the Pliocene, the Pleistocene, and the Holocene. The Miocene epoch occurred 23 to 5.3 million years ago. This is when many modern mammals and their immediate ancestors evolved. Sahelanthropus chidensis is thought to have lived during this time. During this time, giraffids Hominins, Giraffa-ocarix, and Canthameryx emerged. The Pliocene epoch spans 5.3 to 2.6 million years ago. The Pliocene climate was characterized by a warm early period, with temperatures 2 to 3 degrees higher than today, followed by a gradual cooling that led to the onset of modern glacial-interglacial cycles. Australopithecus, an ancestor to Homo sapiens, arose and became extinct during this time, and they likely came into contact with giraffid Brahmatherium, and possibly even the newly emerged Sivatherium. The Pleistocene epoch is when the most recent ice age began, from 2.6 million to about 11,700 years ago. During the Pleistocene epoch, several hominin species coexisted, including Homo erectus, Homo heidelbergensis, Neanderthals, Denisovans, and early Homo sapiens. There is strong evidence that early humans interacted with giraffids during this time, using them as a source of food. We will cover this in more depth later. Sivatherium went extinct during the Pleistocene, and predation may have played a factor in their extinction. We are currently in the Holocene epoch, and it began 11,700 years ago, following the last ice age. It is marked by human expansion and the extinction of most megafauna. The Holocene epoch is the current interglacial period following the last major ice age, meaning the vast ice sheets that covered large parts of the Earth during the last glacial period have retreated. By the time the Holocene began, the wild climate fluctuations of the Pleistocene had tested the species of the time. Many of them did not last into the Holocene, including Sivatherium Giganteum and Homo neanderthalensis. So, if Sivatherium went extinct, how do we know they existed? How do we know what they looked like, what they ate, and what their lives were like? The answer is simple: fossils. Fossil evidence combined with observation of other extant giraffids can give paleontologists a very good idea of how their bodies looked, what they ate, and where and how they lived. While we can't know everything about Sivatherium, we can make some really useful inferences from the information we have. First, let's look at the Sivatherium's body. The Sivatherium body plan is similar to other giraffids, but primarily resembles the modern okapi. Fossil findings include skulls, teeth, ossicones, and postcranial remains, like vertebrae, ribs, humeri, tibiae, and limb bones. These fossils have been discovered across a wide range, from the Sawalik Hills of India to various locations in Africa, such as Morocco, Ethiopia, Chad, and South Africa. The first fossil discovery of Sivatherium was made in 1836 in Sawalik Hills, India, by Falconer and Cotley. In 1892, French paleontologist Auguste Pomel received fossils from another site close to Lake Tanganyika. They consisted of a fragmentary cranium, a molar, and two distinct ossicones atop the skull. Since then, fossils have been found in Ethiopia, Chad, Uganda, and Morocco. In 2022, Suresh Kumar reported on the discovery of new fossil material in the Upper Sawaliks in northwest India. This was the first record of the species in that region, and it was nestled within stratigraphic position of the early Pliocene. This discovery expanded the known range of Sivatherium Giganteum, both geographically and temporally. In 2016, Basu, Falkingham, and Hutchinson used 26 fossilized bones from the Natural History Museum in London to build a 3D composite skeleton and calculate its mass. The estimated adult body mass of 1,246 kilograms surpassed original estimates, making them among the largest ruminants ever known. Together, all these discoveries let us reconstruct the life of a Sivatherium. From the widespread fossil distribution, we can infer Sivatherium occupied diverse habitats across Africa and Asia. From its fossil remains, we can infer its body plan, eating habits, and even aspects of its behavior. It likely browsed on tougher vegetation and possibly competed for mates, much like other giraffids. From mass estimates and digital reconstructions, we can infer its biomechanics, energy demands, and ecological impact as one of the largest known ruminants to ever exist. And from the stratigraphic context of new fossil finds, we can clarify its timeline, track its expansion across continents, and make estimations about how global climate change influenced its evolution and eventual extinction. Among Sivatherium's most common predators would have been Meganterion, a prehistoric saber-toothed cat that lived in North America, Eurasia, and Africa, Dinofelis, a false or near saber-toothed cat that lived in Europe, Asia, Africa, and North America, and our ancestor, Homo erectus. There is an archaeological site in Tanzania called Bell's Korongo, BK, that shows anthropogenic activity related to the exploitation of megafauna, including Sivatherium, and smaller game, the remains of which display a high frequency of cut marks that undeniably indicate butchering activities by Homo erectus. On this slide, you can see examples of the stone tools Homo erectus is known to have fashioned and used, as well as an example of the types of cut marks those tools make, in this case on a proboscidean fossil. So what caused the demise of this big, beautiful, glorious beast of Shiva? The short answer? Natural selection. Ultimately, the climate changed faster than Sivatherium Giganteum could adapt. At the end of the Pleistocene, the planet went through major warming events. Ice sheets melted, rainfall patterns shifted, and ecosystems reorganized on a continental scale. For a giant, specialized browser, that's a disaster. Sivatherium thrived in mosaic habitats, woodlands, river valleys, and savannas rich in shrubs and trees. As temperatures rose and climates dried, those environments collapsed into grasslands. Big browsers like Sivatherium couldn't just switch to grass. Their anatomy, metabolism, and digestive system were all tuned to a different diet, and their body size required huge caloric intake and stable vegetation year-round. So as forests shrank, energy costs went up, birth rates went down, and populations crashed. At the same time, humans were becoming a more persistent pressure on the landscape. Hunting alone probably didn't wipe them out, but it definitely helped push an overtaxed species over the edge. By the time the Holocene began, about 11,700 years ago, Sivatherium and most of the giant mammals that shaped Pleistocene ecosystems were gone. And the world they needed, a cooler world with patchy forests and high biomass vegetation, was gone with them. In just a few million years, Sivatherium Giganteum evolved from modest Miocene browsers to one of the largest known ruminants ever to walk the planet. But, for all their ecological influence, for all their millions of years of existence, even they vanished without a trace, fading even out of the memory of the many species that evolved alongside them. Today, the only extant giraffids are giraffes and okapis, and someday, they'll probably be extinct too. When we study Sivatherium, we are reconstructing the fragile intersection of climate, anatomy, and behavior that made its existence possible. Their disappearance was the inevitable outcome of a world in motion, and that's why this magnificent creature is a perfect example of the idea that survival isn't about being the biggest, strongest, or smartest. It's about fitting into the narrow ecological window that geological and evolutionary circumstances allow. What I love about paleontology, paleoanthropology, and prehistoric studies in general is that the billions of extinct species are a reminder of how dynamic, impermanent, and specialized mammalian life on Earth really is. The conditions of Earth that gave rise to Sivatherium, and indeed to humankind, were so random and will likely never occur on this planet again. And even if they did, species like Sivatherium and Homo sapiens would not likely re-evolve after extinction. The Sivatherium illustrates a paradox, that evolution produces extraordinary diversity and rewards specialization, but extinction is the default consequence. Most species that ever lived are gone, and most species alive now will vanish too. Sivatherium is not an exception, it's the rule. And recognizing that provides a delightfully humbling perspective on humanity's place in the fossil record. Temporary, contingent, and ultimately inseparable from the fate of the environment that built us.